R. Shelby from Wells Institute of Science, Technology and Advanced Studies from India. Hello, Dr. Shelby. Are you ready with your presentation? Hello, Dr. Shelby.
Yeah, ma'am, I'm ready with my presentation.
Okay,
Yeah.
perfect. Then I'm going to make you the presenter.
Okay,
Yes.
ma'am.
Can you please share your screen?
Sure, ma'am. 1 second. Yeah. Ma'am, on, ma'am, is
Yes,
my
we can.
PPT?
Your screen is visible.
No, ma'am, my PPT is visible.
No, no, you need to share the whole window. Yes, now it is visible.
Now it is visible, ma'am.
Yeah,
Is that
you
fine?
can make it a full screen.
Okay, sure, ma'am. Is that fine, ma'am? Is that visible now?
Perfect. Yeah, perfect. Please continue.
Okay. Shall I start, ma'am? Yeah. Good evening, everyone, and thank you for this opportunity for giving me this to present in this conference. So, I'm Dr. Arthur. I'm working as assistant professor in Department of Bioengineering, BTech Biotechnology from Vistas, Chennai, India. So, I'm here to present the work on the algal polysaccharides for 3D printing. So this is my synopsis. So we are going to see about the introduction. What are the types 3D printing process generally available? So I have chosen the algal material. So in this algal materials, there are two types are there: cell wall based and storage based. Ma'am, am I audible? Shall I continue? Hello, hello, ma'am. Am I audible? Shall I continue with my presentation? Hello, hello. Can you tell me, ma'am? Can I continue? Hello.
Yes, 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 it is audible. Yes, I'm sorry.
Yeah, thank you so much, ma'am. And the how the polysaccharide we may be used for 3D printing. So among the polysaccharides now we have chosen the agar, kappa, carrageen, and vulva, which is a predominant type of polysaccharide which is available in three different types of algae, and the future perspective and conclusions. So coming to the introductions, as we all know, how, the 3D printing it is used in the diverse sector, which includes healthcare, automotive, food, architecture, fashion, aeronautics, and defense. So the common material which is used in the 3D printing may be metal, ceramic, or petroleum-based plastics. So that's why there is a lack of biodegradability or biocompatibility of this kind of synthetic materials. So that's why we are going for to choose the bio-based renewable material, which is known as the biomaterials. So among this, I have highlighted the algae, so which holds a promise as a potential feedstock for this 3D printing. So the special feature of this algae is it have the rheological properties which may be suitable for the 3D printing. And this is the common 3D printing technologies which is used in the tissue engineering applications. So the generally the 3D bioprinting techniques it is classified into three types. The first one is the inject based, laser based, and extrusion based. So among the inject based, there are two types of classifications are there. One is the thermal and piezoelectric. And coming to the extrusion based, there are two types: pneumatic and mechanical mode. In the mechanical mode, we are using the two subtypes as piston and the screw type. So and this picture clearly explains the inject bioprinting, extrusion bioprinting, and laser bioprinting. So in the inject bioprinting, we are using the bio ink and the heater is in the side of the thing with the help of the vapor bubble or piezoelectric actuator. So it may be formed as a bubble type. And in the extrusion printing, we are using the two kind of thing that is pneumatic and piston type of thing. So here we are getting without bubbles, it will get a linear flow of the printing. And in the laser printing, we are using the pulsed laser and the donor layer, which may be it act as an energy absorbing layer. So it will we will have the output as a ribbon type. And the main factors which may be taken into account for this bio-based materials are there are three factors which includes printing process and the ink properties what we have chosen and the scaffold design. So coming to the printing process, there are many types out there, that is nozzle speed, nozzle height, support baths, printing angle, extrusion pressure. And coming to the ink properties, we are taken into account viscoelasticity, viscosity, gelatin gelation kinetics, and shear thinning characteristics. And coming to the third factors, it is a scaffold design. So we have to take into account the pore size, what line thickness we are needed, and the strand orientation, and also the line height. So among the various factors, these three factors play a major role when we taken into the 3D printing factors. And coming to that biomedical applications, as we have already seen, there are three based types of things: the printing process, inject based extrusion, and laser assisted. So after making a complex contrast from the algal polysaccharides, we can use for various biomedical application, which involves wound healing, tissue engineering, and also drug delivery, which is the most predominant sectors in the biomedical side. And as we all aware, there are generally two kinds of biomaterial which is available in our sources. One is a plant-based material, another one is the marine plants. So I am focusing on this marine plants. Among the marine plants, there are three different kinds of algae out there: green algae, brown algae, and red algae. Due to the presence of the pigment, we are naming it as the three different kinds. Among the green algae, Ulvan is the most predominant polysaccharide which is available in that, and in brown algae we can tell it as the alginate and the fucadin, and in red algae we can name it as the agarose and carrageenan. So after getting these kind of polysaccharide, we can make it for the 3D bioprinting of tissues and organ, which involves the various steps in the 3D printing. So and we can target it for biomaterial engineering, drug delivery, and also for medical prosthetic kind of products. And as I already told in the introduction, in algal material, there are two different kinds of things are there. We can be used as a 3D printing. One is a cell wall based polymers we can extract, and another one is the storage based polymers. So among the cell wall based polymers, there are agar, alginate, cellulose, carrageenan, fucadin, ulvan, porphyrin, xylan, and mannan is there. In the storage based polymers, there we have laminarian starch, fluoridine starch, paramylin, polyhydroxyalkanates, cryosomelanin, then calcium spirulane, naviculin, cyanophycin starch, and PKG03 and nostoflon. So these are the two different kinds of polymers we can extract it from the algae. So this is the cell wall based type, which is in the cell wall itself we can extract the polymers and we can use it as for the 3D printing. And second one is the storage based polymers. We have to rupture the thing and we have to release the products, and then we can make it used for the 3D printing. And this is the general 3D printing processes where it explains the what are the stages which we involved in the printing process. Initially the 3D image is converted into by using the CAD software model to generate the visualized motion program with the text based command list of printing, which may be in the background of the work, and which include the ink parameter and the printing directions. So after the visualized motion program, we are converting into the 3D printing process, and after that it is converted into the 3D bioprinter tissue product. And this is the different types of 3D printing technologies, which maybe include the extrusion, material sintering, material binding, and lamination type. And this is the process and what is the principle involved in this printing technologies, and what are the materials we have used. So among these, there are different types of materials are used which will be extracted from the algal. So different kinds of polysaccharide, for example alginate, agar, carrageenan. So these are the different kinds of polysaccharide which will be extracted from the three different types of algae, namely red algae, brown algae, and green algae. And this is the some of the commercial type of polysaccharide which will be used as a 3D printing. So the first picture clearly explains the laminaria saturnaria, which is a predominant brown algae. So and the second one, they depicted that cultivations of the microalgae in the outdoor raceway ponds way. And the third picture, it clearly explains the freshwater bloom. And the fourth one, it explains the dewatered algae, which may be used as the alginate and the agar gel. And below pictures, it explains clearly that a bioprinted full-size model of the adult human heart using the alginate. So alginate is a compound which is predominantly present in the brown algae. So they are using the alginate to make a size of the adult human heart. And the last one is the 3D printed human ear by using the nanocellulose alginate they are using. And the last picture clearly explains that from the algae they are using the footsteps like that. And coming to the next, this is the application of agar and the composites which may be used in the 3D printing. So among that, we cannot use the agar as such. We have to go with the blended with some other material, so that for the rheological properties and also stability of the agar. So here the agar is blended with the gelatin and also glucosamine, chitosan, collagen based, and also with alginate and agarose, and fibrinin, and also with nanohydrofobis. So this combination will make us a scaffold type, and which may be converted into the porous 3D scaffold. After that, we have to choose the which type of printing structure processing is useful for making a final product. This is the cross-linking mechanism, and in what application we can be used. So this will give the outline of how the application of agar can be used in the printing process by choosing the correct structure processing in the 3D printing. And this is the application of kappa carrageenan. Kappa carrageenan is one type of the polysaccharide which is present in the red algae. In the red algae, there are three types of polysaccharides are there: kappa carrageenan, gamma carrageenan, and delta carrageenan. So among the kappa carrageenan is the highest amount of polysaccharide which will be available in the red algae. So here also it can be blended with some of the common materials like epoxy, azin, xanthangum, polyacrylamide, nanosilicates, and thiamine. So we can choose the proper 3D printer types, and also we have to cross linking that, and depends upon what applications we are using for. And third one is the application of the ulvan in the 3D printing. So here also we have combined with the some of the stability products, and we have to choose the which type of structure processing and electrospinning, solvent casting, and molding processing. So depending upon the applications we have to choose. And ulvan is the type of polysaccharide which will be present in the brown algae. So it is a predominant kind of polysaccharide. There are various polysaccharides are there. Among that, the most predominant polysaccharides which we focus for the 3D printings are from the brown algae and the red algae. So here we are trying for the our research. We are taken the red algae because here the polysaccharide content is higher when compared to the brown algae. So and what we are doing is we are converted into the by using the nanotechnology process. We are converting into the nanoparticles. After that, we are fusing with some of the protein in order to have the stability of the thing. And finally, we are targeting to convert it into the 3D products. So here, what we are aiming is we are trying to replace the plastic kind of products which are use of the red algae, along with the converting into the nano form, and along with the fusion with some of the stability proteins. We are trying to make it as a non-toxic and biodegradable material which may be eco-friendly in our environment. And coming to the global 3D printing market, so as we all aware of, there are different kinds of sectors which we are depending upon this 3D printing. So the market value maybe 12.6 billion in 2021, and may be projected to reach the 2026 to 34.8 billion with annual CGR of 22.5%. And the future perspective may be, so we are on the way to explore the biocompatibility and also regenerative capacity, and we are doing it in the toxicity studies in the animal trials, which will useful for to allow for the human testing. And also we are focusing on the eco-friendly solvents to improve the extraction yield also. And some of the technical and logistic challenges are there to making as a harvesting, and also to address the biotoxin which may be accumulated in the macroalgae. And so in future, we are also incorporating along with the 3D printing. We are trying to isolate the bio ink from the polysaccharide. So normally there are different kinds of polysaccharides are available: seaweed derived, plant derived, and crustacean derived, and microbial derived. So among these, we are focusing on the manufacturing of bio inks from the seaweed derived polysaccharides. So among them, we are targeting for the alginate based bio inks, which may be predominant thing which may be present in the brown algae. And these are the references for our work. And thank you. Any other questions? Can you hear me, ma'am? Can anybody hear me? I
Yeah,
finished my.
yeah. Yes,
Yeah.
yes. Thank you, doctor, for your presentation. So, any questions? Okay, no questions. Then thank you once again, doctor, for your presence and presentation.
Yeah. Thank you so much, ma'am.
Okay, thank you.